Hi folks, this is Nat, and this is going to be your video lesson on division, specifically division of both whole numbers and decimals. A division problem is broken up into a couple different pieces. The dividend is the value that you are dividing, and the divisor is the number you're dividing by. You might also remember that the quotient is the solution. But for today, what we're going to be focusing on is division by a whole number, but being done to either whole numbers or decimals. But before we get into that, there's one thing that we probably want to touch base on, and that is the really most common mistake that you want to avoid when you're doing division or setting up a division problem. The biggest issue that students seem to have, at least kind of setting up their problems, is the fact that division is not necessarily said in the way that it's set up. So for example, the way I say division might be like this: 852 divided by 14. The problem is that when students go to actually set that sort of a problem up, they want to use the more standard long division method, and they forget that that's backwards. So this is the same problem, 852 divided by 14. And you're going to notice that in word form, the way I say it is actually backwards from the way that it's written. So when I say 852 divided by 14, I set it up backwards with the 14 first and the 852 second. 852 divided by 14. So make sure when you're setting these things up to start with, you remember that. Otherwise, you obviously won't get the correct answer. So we're going to start off with sort of a general division review, focusing on whole numbers right now before we get into the decimals. And unfortunately, once you start getting into decimals, there's really no substitute for standard long division, by which I mean the way of setting things up that looks maybe like this. Let's say I want to do 468 divided by 9. First of all, notice how I set it up backwards, or what would be said in the opposite order that it's written. Some of you are in the habit, probably from 3, 4, 5, of doing this and doing the partial product division, where you sort of take an estimate and see what you have left, and you kind of do another estimate and you see what you have left, and you might end up kind of doing like, well, I know that 9 goes into 400 maybe about, I don't know, 5 times, so 59s. And then you kind of work your way through this thing where you're like, okay, 450, and then you see what's left over, and so, okay, I've got 18 left over, and now it's 2. And then you add these things up. 50 and 2 makes 52, so 9 goes into 468 52 times. Well, the problem is that that only works as long as you don't have to add on decimal places. Once you start getting into decimals, and particularly decimals that don't end necessarily, you all have seen a lot of decimals that go on forever and ever. When you start dividing numbers where that's the case, for the quotient, the answer, that method no longer works. So unfortunately, for those of you who've been relying on that partial product division for so long, you don't really have much of a choice. You're going to have to switch to doing division the sort of standard, old-fashioned, traditional way. But thankfully for you, it's actually pretty easy, especially when you're dealing with whole numbers and divisors that are whole numbers and values of only one digit. So like this. So what we're going to do is one of two things. You can use long division, or you can use division short form, and they end up doing the same thing. One's great for doing things quickly and writing fewer things down for those of you that like your mental math more. But as a quick review, if I want to do 9 into 468, or 468 divided by 9, I'm going to start by looking at the 4, and 9 doesn't go into 4. 9 goes into 4 0 times, which is 0, and I subtract, and I have 4 left over. and then I bring down my 6, and I say, how many times will 9 go into 46? Well, 9 times 5 is 45, so it'll go in 5 times, which is 45, and we subtract, and we have 1 left over. I bring my 8 down, and 9 will go into my 18 here 2 times, and 2 times 9 is 18, which leaves me with nothing left over, and I'm done. So I get the same answer here, 52. That way is great. It takes up a lot of paper, though, and particularly when you're dealing with one-digit numbers, there's a faster way you can kind of get through that stuff. So let's rewrite that problem real fast. And now I'm going to take you through short form division, which for a lot of us is a nice, easy way to get through a division problem quickly. And it basically involves one simple idea, which is how many times will the divisor go into whatever number I'm working with, and how much is left over. So for example, 9 goes into 4 0 times, with 4 left over, because I haven't taken anything from the 4. And instead of doing all of this subtraction stuff that I do over here and this bring down stuff, I can just take that 4 and write it next to the 6. And now I'm looking at this as being 46. 9 goes into 46. Well, 9 times 5 is 45, so it goes in 5 times. And since that's 45 and I'm comparing it to 46, there's 1 left over. So I'll carry that 1, and I'll treat this next value as 18, the 1 and the 8 together. 9 goes into 18 2 times. There's 0 left over, so I won't carry anything. And that's it. That's short form division. I'm going to show you one more example of short form division. Let's say I had to do 1,518 divided by 6. All right, same thing as before. 6 goes into 1, 0 times with 1 left over. 6 goes into 15 twice, which is 12, so there's 3 left over. 6 goes into 31 5 times, which is 30, so there's 1 left over. And 6 goes into 18 3 times, which is 18, so there's 0 left over, no remainder for my division. So 253 would be my answer. You can really get through division quickly that way, provided you're good with your multiplication facts. That said, I don't honestly mind how you do your division. Provide one of these two methods, no partial product. Again, you'll have trouble with decimals. You just need to have a method that you feel comfortable with, that you can do correctly most of the time. The really nice thing about this is that if you are good at your regular whole number division, adding the decimal is really, really no big deal. Because much like multiplication, we more or less ignore the decimal until the end of the problem. Let me show you what I mean. Let's say I'm doing 22 75/100 divided by 7. Well, first of all, I need to set that up correctly. So remember, it's reversed when I set that up. So 7 goes into 22 75/100 how many times? So same problem. You'll notice when I write it the two different ways, it's in the opposite order. So same idea. Now, the big thing here is I'm going to ignore the decimal entirely. I'm basically going to pretend it isn't there. And I'm going to do the same thing I just did in the last problem. And I tend to like short form division, so I'll demonstrate that first. If you don't like short form division, you can use long form division. That's fine too. 7 goes into 2 0 times with 2 left over, because I haven't taken anything away. 7 goes into 22 3 times, which is 21, so there's 1 left over. 7 goes into 17 2 times, which is 14, so there's 3 left over. And 7 goes into 35 5 times, with nothing left over. And that's my answer so far. The only thing that's added by adding the decimal is that when I'm done, I'm going to bring my decimal directly up and put it exactly where it was before. You're going to notice a lot like multiplication. There were 2 decimal points in my original problem. There will be 2 decimal points in my answer. And that's really all there is to it. We'll do one more example of that, and this time I'm going to use my long form division for those of you who prefer that. So we'll do 21 and 68 hundredths divided by 8. And again, I have to set that up correctly. So I'll do 21 and 68 hundredths divided by 8. And here we go. We're going to start by saying how many times will 8 go into 2, and that's 0. 0 times 8 is 0. Subtract. Bring down the 1. 8 goes into 21 twice. That's 16. And I'm going to subtract, which involves some borrowing here. That's a 5. And I'll bring down the 6. 8 goes into 56 exactly 7 times, which is 56. So there's nothing left over, and I need to bring down the 8, and now 8 goes into 8 once. And I ran out of room. This is one of the reasons I don't love long form division, but that would cancel out entirely. I'd subtract the 8, I'd get back to 0, and I'm done. I end up with 271, and again, I just have to bring that decimal straight up. I had 2 decimal places in my problem. I will have 2 decimal places in my answer. And that really, really is all there is to it. So hopefully that feels pretty manageable. The one area this may get a little bit more complicated is when we're dealing with divisors, the number we're dividing by, that are a little bit bigger, particularly 2-digit numbers, even 3-digit numbers. So let me give you another example. Let's say I'm doing 81 and 77 hundredths divided by 17. Again, I'd need to set that up correctly. So 17 on the outside of the box, 81 and 77 hundredths on the inside of the box. The big thing here is that the thing that makes this difficult is that pretty much none of us know our multiplication facts for 17. If you really want to save yourself some trouble, the thing I recommend is actually listing out very quickly the first 9 multiples of 17. So basically saying 17 is obviously my first, 17 times 1. 17 times 2 would just be 17 more. I can add 17, call that 34. I can add 17 again, and I think that's 51. I can add 17 again, I end up with 68. Add another 17, and that's 85. I can add another 17, and so on. And there I've listed all of the first 9 multiples. You can stop at 9 because you'll never need more than 9, which is kind of a nice thing. And it takes a little bit of time to get them all down, but it's just adding 17 over and over again, and it might actually save you time in the long run. So now we do the same thing. We say 17 goes into 8 0 times, and I know that because 17 is bigger. But then when I get to the 81, carry the 8 or do whatever you do, subtract if you want. When I get to the 81, now I'm looking at my list that I've already made, and I'm saying, what's the biggest without going over? And that one's 68. So I know that that's my 4th multiple, so 17 goes into 81 4 times. And now I don't have to do the multiplication here because I've already done it. 4 times 17 is 68. And then I can do my subtraction, which is 13. And then I can bring down my thing. So having that information already available means I don't have to be doing it as I go. I just do it to begin with, save myself the trouble. So now I'm thinking 137, having brought down my 7. And I'm looking over here, and I see 136 is the closest without going over. That's my 8th multiple. So it goes in 8 times, which is 136, which means 1 is left over. And I'll bring down my 7. This is an easy one. 17 goes into 17 once, and with nothing left over, I'm done. Last thing, again, is to bring up that decimal. So, again, bigger numbers are not really a big deal, especially if you do this. Take the time to list those multiples. It actually speeds things up in the long run. Because the biggest thing that makes large division like this feel difficult is the fact that we don't know our multiplication facts for it, for the divisor. And here are your practice problems for this lesson. Keep in mind, regardless of what method you use, you do need to show your work for these. Alrighty, good luck.